We have already used the brute force algorithm to find the solution of motif search problem. So as we know that the running time of this algorithm is very large. So with the worst running time of big O L dot n power t, so it means that the running time is too large. And with this too large running time, the practical problem of this algorithm is that we cannot use this algorithm to solve the biological problems, and we cannot use this algorithm for the biological samples. So to overcome this problem, we have chosen another algorithm, that is greedy algorithm, and we have chosen because of its fast running time. And we already know that this greedy algorithm is not correct, and it do not provide the correct answer and good approximation ratio. And we also know that this is an approximation algorithm, but still we will use this greedy algorithm to solve the motif search problems. And by using the greedy techniques, although it is not correct and do not provide the good approximation ratio, still the greedy algorithm technique was used to formulate a very good software that is known as the consensus software, and it was developed in 1989. And this consensus software provides a solution for many of the biological problems, especially the motif finding problems, and it gives results that are very good and are comparable to other algorithms that are very complex. Greedy motif search algorithm scans each DNA sequence only once. So this is the beauty of this algorithm, that it will not scan each of the DNA sequence again and again. So this algorithm will scan DNA sequence only once, and then once we have scanned a particular sequence I, we will decide which of its Elmer has the best contribution to the partial alignment, because in the motif search we have to find the motif within the sequence of the DNA, and this algorithm will scan all the sequences once and will select the best Elmer motif within these DNA sequences, and we will come up with the score, maximum score of the alignment as SIDNA for the first I sequences, and then immediately it will be claimed that this Elmer is a part of the alignment. Now we will see the steps of the algorithm that is used in finding the motif search, and this is the greedy motif search algorithm. So here we will must have the DNA sequences, and T is the number of DNA sequences. Here N is the size of the DNA sequences, and L is the Elmer of the motif we need to find within these sequences. So the first step is we will assign the value of 1 1 up to 1, we have already seen in the previous algorithms, as a best motif value. So in the second step we will assign the same value to the starting positions of the DNA sequences, and it is the same as we have assigned this value as a best motif. So in the third step, for loop will apply, and we will assign the value 1 to n minus 1 plus 1. So it means that it will start from 1, and we will minus the sequence of motif we need to find from the sequence of DNA, and we will add one sequence that it will move further one nucleotide. And similar for loop will apply for the second sequence, starting sequence of DNA. And again the same value will apply to this one. So in this case we will first search the first two DNA sequences and will try to find the best motif within these sequences. Then if score means the best score of the starting points of the two DNA sequence is greater than the score of best motif of two DNA sequences, then we will assign the value of S1, here is the S1, as a best motif 1. And similarly we will assign the value S2 to the second best motif score. So it means that we will find the best two motifs in the first two DNA sequences. So next, if we have assigned the value of S1 as a best motif 1 and 2, then we can also say that we will assign best motif 1 value to S1 and similarly best motif 2 value to S2. Then after finding the best values and assigning it to S1 and S2, then we will move on to the third DNA sequence, and that is we will find from third to the end of all of the DNA sequences, that is T DNA sequences, and we will assign this value to I. Then the for loop will again apply and we will assign the same value 1 to n minus L plus 1 to S1, and if the score that we will obtain from Si, I means from we have assigned the value of I3 to T, means the remaining of the DNA sequences, and if we get the score that is greater than the score we have already assigned best score to iDNA, then that best score motif 1 we will assign it to S1. And similarly if we get the best score we will get the answer as a best motif. So the algorithm we use, the greedy algorithm, it basically works to find the best motifs within the first two DNA sequences, and the motifs that it will search will be the closest motif in reference to the sequence. So here we, after finding the motifs, it will provide the 2 into L seed matrix, and then for the each of the seed matrix it will need these numbers of operation to provide the seed matrix. And for each of the T minus 2, because the algorithm has find the DNA sequence and motifs within the first two DNA sequence, then T minus 2 means it will eliminate the first two DNA sequence and then will again search the remaining DNA sequences and will add one of the sequences, and it will be like 3 less than equal to I and I is less than or equal to T. So it will add one of the more rows within these sequences and it will become 3 into L. And for T minus 2 sequences and selecting the one Elmer that has the maximum score, it will achieve the maximum score of Si, and again it will need these numbers of operations. So we can see here that the running time of this greedy algorithm is big O ln square plus ln(t), and we know that this time is much vast better than the O ln t of simple motif search or even the O4NT of the brute force median string. So it means we can say that the greedy search algorithm has a much lesser operation time than the other two algorithms, and it also provides the best possible solution in comparison to the other two algorithms.